Well, so welcome you all to the first demonstration of Basic Electrical Engineering Lab. So today we are going to develop one particular circuit in a breadboard which is as given here. Now you could see we are having four resistances 100 ohm, 100 ohm, 470 ohm, 1 kilo ohm which are connected, and these are the respective resistances. These two are 100, this is 470, this is 1 kilo ohm. And we are having two voltages, one is 8 volt and one is 5 volt. So basically we had done what? We had kept that voltage source and kept it here. So the top one, this particular one is actually the plus 8 volt, this is the plus 5 volt, and the negative terminal of both the sources are connected together. You could see the negative terminal connected together and the common terminal that is coming over here. Now we have to realize the circuit what is given over there in the breadboard. So let's see how we are going to have it. So the first thing what we need to do is to connect this 8 volt to 100 ohm. So this is 100 ohm. I am taking out and I am keeping it somewhere. See. Yeah. So I connected 100 ohm resistance, and as you know that in case of a breadboard, these terminals are electrically isolated in this way, and in this way they are electrically shorted. Similarly, this is electrically shorted, but this and this they are electrically isolated. Now I have to connect this 100 ohm resistance to plus 8 volt. The plus 8 volt is the topper one, so I am taking out one from this terminal and then connecting it here. So from this to this thing is done. Now at this common point, what I need to do, I need to connect another 100 ohm resistance over here. So let me connect that 100 ohm resistance I had connected. So from this point to this point I had come. Then I would be having 1K. So I would be connecting that again. So this 1K is also now connected. Now the N terminal of this 1K it needs to be connected with the ground. So let us connect that. So from this negative terminal it is going to the 1K. So the negative terminal is actually going to 1K. So the external circuit is complete. Now coming to the internal one, what we need to do, we have to connect the 5 volt source with the 470 ohm resistor. So this is a 470 ohm resistor. Let me take it here and place it like that. This is the 470 ohm resistor what I had connected. Now you could see that the N terminal of this 470 ohm is to be connected to the common point. So now I will be connecting the common point, that is this point should be shorted with this one. So this is okay up to this much. Now what we need to do, we have to apply the 5 volt source. So from where the 5 volt is coming, 5 volt will be coming from this point. The 5 volt will be coming and this will be applied to the other terminal of this 470 ohm. So you could see whatever is there in the circuit, we are now connected it there. So let us explain it in an overall manner. From this 8 volt, it is connected to 100. So 8 volt is the upper one. It is going to the 100 ohm. From the plus 5 volt is going to 470. So plus 5 voltage, this one is plus 5 volt. So and going to 470. Then the 470 is connected to the other terminal of the 100 ohm. So this loop is okay. Then the common point, the common point is connected to 100 ohm, so it's connected. Then with the other terminal of the 100 ohm, we are having the 1 kilo ohm connected, and then from 1 kilo ohm, the terminal is going to the negative side. And what exactly we had done, we had actually shorted the supply, the negative terminal there only. So you could say that the whatever circuit I had drawn there, that actually is being realized in the breadboard. Now we are going to have the different operation, what we need to do. Now what we need to do, that we are trying to find out what is the current through this 1 kilo ohm resistance. Let us assume that this is the load resistance. So what basically we have done, to determine the IL, we have to find out this IL. So we are connecting ammeter in series with the 1 kilo ohm resistance. So what we have done, basically we have taken two terminals, one from the negative terminal, one from the output of this 1 kilo ohm, that is actually going towards the current measurement system. You could see there. You could see that the current is showing some value, that is 6.7 ampere is showing, that is the 6.7 milliampere more precisely I could say. That is basically the current that is actually passing through this 1 kilo ohm resistance for this particular case. Now finally we are going for the next thing, that we are finding out the short circuit current of the arrangement, which is also called the Nortons current. So basically the circuit would now become something like this one. We could see that we are replacing the load resistance and we are shorting it together and connecting the ammeter there. So what we have done, basically, this is the circuit. I am not touching the circuit now. Basically what I am doing, I am now removing this 1 kilo ohm resistance electrically from the circuit. Previously what I had done, I was connecting it to this terminal to have some output current. Now what we are doing, I am just removing that and I am connecting it to the other terminal. So electrically now it is acting like a short circuit condition, because physically it is there but electrically actually no current would be passing. So what is happening now? So whatever current is passing through 100 ohm, that is actually now passing to the circuit, and now you could see the reading. It is having some 44.7 ampere. So that is basically the short circuit current, I could say. That 41.7 is basically in milliampere. So we had found the short circuit current. Next, what we need to do is to find out the Thevenins equivalent or open circuit voltage of the system. So what we have to do, that we have to open circuit it and measure this voltage. So basically you have to connect a voltmeter between this terminal and this terminal. So what I had said, that basically this wire is basically coming out of this point, and this wire is basically coming out of that. So I am taking out that two wire and trying to measure what is the voltage between that. So let me take a multimeter probe there and try to measure the voltage. So I am connecting it to the negative terminal and to this probe. I am going to see that what is the value of voltage. So we could see there that the voltage is coming to be 7.9 volt. So I'm just now rearranging the circuit a bit. Some wire had actually come out, so let me tighten it. Yeah, so this is what the way basically I need to measure the Thevenins equivalent voltage of the system. Now, as my both of the hands were actually struck over there, so I couldn't show you what was the reading. I had said that is equal to 7.95 or something like that. So I had actually now settled the thing. Now you could see that there is a multimeter there which is showing now 7.9 volt. So that is basically the value of VTH of this particular arrangement. So what we had found, that for this particular circuit we had determined that what about the load current it's actually going to have, what about short circuit current or Nortons current, and what about the open circuit voltage or Thevenins voltage. We had found the three things. Next what we are going to do, we are going to find out the Thevenins equivalent resistance of this particular circuit. So let's see how we are going to have it. Now to find out the R equivalent or the Thevenins resistance of the arrangement would be something like this one. We would be deactivating the voltage sources or simply short circuit the voltage sources, assuming that the sources are having in zero resistance. So basically what we have to do, that whatever connections were going to the sources, we have to put it to the ground. So you could see previously what was done, that this terminal and this terminal of the resistance, this is 100 ohm. So 100 ohm was connected to 8 volt supply. So that will be connected here. Now we will be taking it out and putting it to ground directly, because now it is connected to the ground common point. And this terminal was connected to 5 volt source. So previously it was to the upper side. Now we are taking it out and putting it to the ground. So virtually we are doing what? We are actually going towards this sort of circuit, and 100 ohm as it is there. Now from this 100 ohm and this ground, actually we would be taking two terminals out and trying to see that what about the resistance. So I had used the multimeter here to check the value of resistance, and you could see that it is giving some 180 point some value, 180.1 right now. It is giving, it keeps on fluctuating depending on the some movement in the system or not. So that is what actually we are going to find. So what we had found the value of load current, we had found the Thevenins resistance, we had found the short circuit current, we had found the open circuit voltage. So a lot of things we had found. So from all these things we are trying to investigate that what about the variation of the result that is obtained if we are trying to find it out physically. So comparing the theoretical and practical results, we will be finding out the percentage error and try to analyze that why there is some error that is actually creeping in. Ideally there should not have any error, but practically some errors are creeping in. So we are going to investigate how actually this error is coming out. So this is here for this video. I am stopping here. In the next video, we'll be discussing that what about the calculations and how we are getting the result and how we are going to find out this percentage error. So thank you. Have a nice day.